Okay, today we're going to look at factoring two terms. Now, so far we've done where we, first thing we always want to do is check for a common factor. If it doesn't have a common factor, then we look at the number of terms. So 4 terms, we factor by grouping. 3 terms without a coefficient, we do what we call read backwards. 3 terms with a coefficient, we do what I call multiply, divide, reduce. You can go back and look at those videos. And then today we're looking at what to do with 2 terms. So there's 2 things that can happen when you have 2 terms. It can be a perfect square or it can be a perfect cube. And so I'm going to show you what to do for both of these types. But first, let's talk about what a square means. What's a perfect square? Well, a perfect square is a number that has the same number times itself that gives you that. So some of our perfect squares are 4 because the square root of 4 is 2. The square root of 9 is 3, and I apologize for the shaking. I've bought different tripods, I've tried everything, and it still is shaking. But so 4, 9, 16 is the next one because it's 4. And so do you see, you really can list these whole numbers up to 10, and then when you multiply by himself, it gives you the perfect square. So the square root of 25 is 5, square root of 36 is 6, square root of 49 is 7, square root of 64 is 8, square root of 81 is 9, and square root of 100 is 10. So when you have the difference of 2 perfect squares, and so that what that means is that this number here is a perfect square, that the number, the coefficient that you have is a perfect square. And if that's the case, then you can split it into 2 different parentheses. I'll show you the little trick, but before I show you the quick trick, let's look at if we did it with 3 terms without a coefficient. So if we wrote this as x squared plus 0x, because we don't have an x term, that would be like a 0x minus 25. Now it is a trinomial, so we can factor it by reading it backwards. So I want factors of 5 that subtract to be 0. So do you see that would be 5 times 5. So we would use our 2 parentheses like we did before. We'd have our x and x, our 5 and our 5. First sign would come down. And we're subtracting, so the signs have to be different. So you can use that trinomial, but you have to think about of having that 0x there in the middle. But the easiest way for a difference of 2 perfect squares is just know that you split up your 2 parentheses. You take the square root of 25, which is 5 and 5. You take the square root of x squared, which is x and x. And then you make one of them negative, one of them positive. It doesn't matter which one's which. You can do plus 5 minus 5, or you can do minus 5 plus 5. The order on those doesn't matter. It's just that you take the square root of everything and then make one negative and one positive. So this one, the square root of 100 is over here is 10. So we're going to do our 2 parentheses, our 10 and our 10, our x and our x, make one of them negative and one of them positive. It's easy as that. Now the problem with this though is this says the difference of 2 perfect squares. If it's a plus right there, it won't work. This answer is prime. But let me show you why. If we wrote this as a trinomial, this would be x squared plus 0x plus 49, which is asking for factors of 49 that add to be 0. Well, there's not any number alive that can add to be, any number in nature that can add to be 0. Well, integers, negative 1 and positive 1, I'm sorry. Any of the same number that could add together to be 0. And so that's why these are prime. So if this is a plus, your answer is automatically prime. It doesn't matter what the rest of the numbers are. You want to just write prime. Now this next one can be a little confusing, and I'll show you both answers, and some people will count the first one right. It's just not in simplest form. But when you use our steps for solving factoring, we're really supposed to always take out a common factor. And do you see that 16 and 36 both have a 4 in common? So before you do anything else, you need to do step 1, which is factor out the common factors. So 16 divided by 4 is 4x squared. 36 divided by 4 is 9. So you really should factor out that 4 first. And now what's left here is the difference of 2 perfect squares. So the 4 would come down. You do your 2 parentheses. The square root of 9 is 3 and 3. The square root of 4 is, or 4x squared is 2x and 2x. make one of them negative, one of them positive. And so that's the simplest form of the factoring and really the way that I really want you to answer it. But sometimes people get in a hurry and they just say this is the difference of two perfect squares. And so they factor it as 6 and 6, 4x and 4x. One of them's negative, one of them's positive. And I have a hard time counting that wrong because you can, when you set it equal to 0, solve it correctly. So I probably won't count it wrong, but if you're in college algebra, they really may push to have in simplest form. So this is factored in the simplest form, and then this is just, it's factored, but it's not in simplest form. So look at this next one. First of all, that's not a perfect square. It does have a common factor though. So we can take out a common factor, which would leave us 4x squared plus 5. But then we can't go any farther. There's two terms, but that's a plus. It's not a perfect square. There's nothing else we can do to that one, so we just leave it like that. But remember, don't ever forget step 1, which is factor out that common factor. This next one, difference. They're both perfect squares, so we can go straight to our two parentheses and just say the square root of 64 is 8a and 8a. Square root of 81 is 9, but don't forget your b squared. 9b and 9b. One of them's negative, one of them's positive. Okay, this next one, 144 is a perfect square. It's 12, so if you'd kept going, 11 is 121 and 12 is 144. It's a difference of two perfect squares, so we can split up our two parentheses. And so it's going to be 12 and 12. But now m to the fourth, we ran into these earlier, but you're going to cut that in half. A squared is a and a, so m to the fourth is m squared and m squared. One of them's negative, one of them's positive. But this one is as far as we can go because 12 is not a perfect square. 16 is, 9 is, but 12 is not, so that one is in simplest form. We can't go any farther. I should have spread these out more. But when we look at this one, it's really the same type of problem. The square root of 16 is 4 and 4. X to the fourth is x squared and x squared. One of them's negative and one of them's positive. The difference between this one and this one is this is not a perfect square, but this is. So the plus can't go any farther, but this x squared minus 4 can still be factored to be 2 and 2, x and x. One of them's negative, one of them's positive, and then an x squared plus 4 just comes down. So anytime you have something to the fourth power, once you split it up to 2 and 2, you need to make sure, can I keep going? Is that a perfect square? And can I keep factoring it? This one we can't because 12 is not a perfect square, but this one we can because 4 is a perfect square. So you notice that's when you, that's how you factor anything of the form of an even number, 2, 4, 6, 8. We just do to fourth in this class, but you might have higher numbers in college algebra. But anything of an even exponent, you want to factor it. Well, first you want to check for a common factor, and then you want to look for the difference of two perfect squares. And remember, if it's a plus, you can't factor it. It goes straight to prime. Okay, but now let's look at perfect cubes. So cube root is anything times itself 3 times. So I didn't write 1 on the first one, but 1 is a perfect square. Let me put that up here, that the square root of 1 is equal to 1. 1 times 1 is 1. So the square root of 1 is a perfect square. And it's also a perfect cube because 1 times 1 times 1 is 1. So the cube root of 1 is a perfect cube. And then to get the rest of them, you can just write your numbers and multiply it out, but now we're doing it 3 times. So 2 times 2 is 4, times 2 is 8, so that's the cube root of 8 is 2. 3 times 3 is 9, times 3 is 27, so the cube root of 27 is 3. 4 times 4 is 16, times 4 is 64. So the cube root of 64 is 4. And then 5 is 5 times 5 is 25, times another 5 is 125. So the cube root of 125 is 5. So those are all of our perfect cubes. Now, the difference is square is going to be 2 terms, and it's going to be split in 2. A perfect cube is going to have a different type of process. And in the book, and I could write it down, but there's a formula that you can plug in, but nobody ever really remembers formulas. So I want to show you a process to do. And the best way to do is practice these. I know they say that all the time. Once you've practiced this process, I think that you'll see that it's much easier. But a perfect cube is always going to factor to be 2 terms here. Let's just say number, and then 3 terms here. So binomial times a trinomial is what your answer is going to look like. So the process is for m cubed minus 27, as soon as we see this as a cube, we're going to take the cube root of all that. I just noticed a mistake here. This is supposed to be a 3. And what I mean by that is the cube root of m to the 3rd is just an m. The minus comes down. And the cube root of 27, look over here, is 3. So the first thing you do is you take the cube root of it. Okay. Then you're going to have 3 terms over here. And I know that sounds silly, but it'll make sense in a minute. So we're going to do first times first times second, and then second times second. I should have given myself more room here. And so what I mean is, going back to here, this is first and this is second. So first times first, m times m is m squared. And then first times second, m times 3 is 3m. And then second times second, 3 times 3 is 9. Okay, that's our numbers. And then for our signs, some people call it SOAP to help you remember, but it stands for sign opposite. I'm sorry about the shaky camera. Always positive. So that's just a way to remember your sign. So what I mean is, this sign always comes down, no matter what it is, and then it goes sign opposite. So this is negative, this would be positive, and then the last one's always positive, no matter what. So the sign comes down, and then it goes opposite, always positive. Okay, let's try it again, because that might be a little confusing. So again, this is when we have a cube root here. We're going to do the cube root, which means the cube root of 8 is 2, because 2 times 2 times 2 is 8. The cube root of t to the 3rd is t. The minus comes down, and the cube root of 125 is 5. So we got our first parentheses. Then we draw our parentheses. And remember, it's first times first. So 2t times 2t is 4t squared. Then first times second. 2t times 5 is 10t. And then second times second. 5 times 5 is 25. And then it goes, this came down, this is negative, so it goes sign opposite, always positive. And that's really all it is, and it'll be the same no matter which one you're doing. So let's do one more. So so right here. So we're going to do a parentheses and cube root everything. We've got our cube roots over here. So the cube root of 64 is 4. So that's a 4x minus the cube root of 125 is 5 minus 5y. So that's our first parentheses. Sorry, I've put these two so close together. Then we're going to do our second parentheses, which is first times first. 4x times 4x is 16x squared. First times second, 4x times 5y is 20xy. And then 5y times 5y is 25y squared. And then remember, this sign comes down, and then it goes, whatever this sign is, sign opposite, always positive. And I just realized I didn't do a plus. I should have done that. Now, for difference of two perfect squares, it has to be a subtraction problem. Subtraction is the only thing that'll work for difference of two perfect squares. Perfect cubes, it doesn't matter. It can be plus or minus, and I should have made one of these plus. So let's look at the first one. This can be m cubed plus 27 and still work. A plus right here doesn't matter. You just cube root it all. So this would be m plus 3. The plus comes down. And then it would be m times m is m squared, 3 times m is 3m, and 3 times 3 is 9. The only difference is this was plus, so now it goes opposite, always positive. So if a cube starts out with a plus, then it just switches to minus and then always positive. So I always tell everybody your biggest percentage is plus. So if in doubt, put a plus. But really the first sign comes down, opposite, always positive. So that's 5.4, factoring with two terms.